In the previous video, we talked about the form of the hypothesis for linear regression with multiple features, with multiple variables. In this video, let's talk about how to fit the parameters of that hypothesis. In particular, let's talk about how to use gradient descent for linear regression with multiple features. To quickly summarize our notation, this is a formal hypothesis in multivariate linear regression where we'd adopted the convention that x0 equals 1. The parameters of this model are theta 0 through theta n, but instead of thinking of this as n separate parameters, which is valid, I'm instead going to think of the parameters as theta, where theta here is a n plus 1 dimensional vector. So I'm just going to think of the parameters of this model as itself being a vector. Our cost function is j of theta 0 through theta n, which is given by this usual sum squared error term. But again, instead of thinking of j as a function of these n plus 1 numbers, I'm going to more commonly write j as just a function of the parameter vector theta, so that theta here is a vector. Here's what gradient descent looks like. We're going to repeatedly update each parameter theta j according to theta j minus alpha times this derivative term. And once again, let me just write this as j of theta. So theta j is updated as theta j minus the learning rate alpha times the derivative or partial derivative of the cost function with respect to the parameter theta j. Let's see what this looks like when we implement gradient descent, and in particular, let's go see what that partial derivative term looks like. Here's what we have for gradient descent for the case of when we had n equals 1 feature. We had two separate update rules for the parameters theta 0 and theta 1, and hopefully these look familiar to you. And this term here was, of course, the partial derivative of the cost function with respect to the parameter theta 0. And similarly, we had a different update rule for the parameter theta 1. There's one little difference, which was that when we previously had only one feature, we would call that feature xi, but now in our new notation, we would of course call this x superscript I subscript 1 to denote our one feature. So that was for when we had only one feature. Let's look at the new algorithm for we have more than one feature, when the number of features n may be much larger than 1. We get this update rule for gradient descent. And maybe for those of you that know calculus, if you take the definition of the cost function and take the partial derivative of the cost function j with respect to the parameter theta j, you find that that partial derivative is exactly that term that I've just drawn the blue box around. And if you implement this, you will get a working implementation of gradient descent for multivariate linear regression. The last thing I want to do on this slide is give you a sense of why these new and old algorithms are, sort of the same thing, or why they're both similar algorithms, or why they're both gradient descent algorithms. Let's consider a case where we have two features, or maybe more than two features. So we have three update rules for the parameters theta 0, theta 1, theta 2, and maybe other values of theta as well. If you look at the update rule for theta 0, what you find is that this update rule here is the same as the update rule that we had previously for the case of n equals 1. And the reason that they're equivalent is, of course, because in our notational convention, we had this x0 equals 1 convention, which is why these two terms that I've drawn the magenta boxes around are equivalent. Similarly, if you look at the update rule for theta 1, you find that this term here is equivalent to the term we previously had, or the equation, the update rule we previously had for theta 1, where of course we're just using this new notation, x subscript 1, to denote our new notation for denoting the first feature. And now that we have more than one feature, we can have similar update rules for the other parameters like theta 2 and so on. There's a lot going on the slide, so so I definitely encourage you, if you need to pause the video and look at all the math on the slide slowly to make sure you understand everything that's going on here. But if you implement the algorithm written up here, then you will have a working implementation of linear regression with multiple features.